This video, I will introduce Euler's method, which is basically a numerical method that uses the idea of tangent lines or a short distance to approximate the solution to an initial value problem. So yeah, what is Euler's method? Euler's method is another way to approximate a solution to a differential equation where it's not easy to solve or verify. Euler starts with an initial point and using the slope at that point times the step size like delta h or delta x plus the initial y value, it calculates a new y value and the x value automatically changes based on the step size. So yeah, this is all about approximating. So yeah, here's a graph and yeah, and then here's the steps. So this would be delta x or delta h. So let's just do an example to make better sense. So let's start with example one. So example one says, use Euler's method with a step size of delta x of 0.5 to approximate y of 2 for an initial value y prime of equals to x plus y and y of 0 equals 1. So whenever you see Euler's method, you automatically have to make a table. So let me write that down. Okay, so let's go ahead and make a table. So the first column would be x, the next column would be y, and then our next column is, here, let me write it out. And then this column would be our dy dx delta x plus y. So what do we know? They give us an initial condition of y0 equals 1. So that means your x coordinate is 0 and your y coordinate is 1. So we could put that on the first column. So your x is 0 and your y is 1, right? And then what do we put in here? Well, it's basically it's dy dx times delta x plus y. So our delta x was given, our delta x was 0.5. So it says it's x plus y, so our x is 0, our y is 1, right? So x plus y is 0 plus 1 times it by the your delta x. Your delta x is given 0.5. And then it's plus y, and our y value is 1. So when you put it all together, you get 1.5. Okay. Now let's do, we have to get to 2, the x value 2. So we started at 0. How are we going to get to 2? Well, if our delta x is 0.5, we're adding increments of 0.5 on the x coordinates. So 0 plus 0.5 is 0.5, right? And then what is our y? The y value is this answer right here. So our y value will be 1.5. Okay. And then you just do the same process again. So it's x plus y. So it's our x is 0.5 and our y is 1.5 times it by our delta x, which is 0.5, plus my y, which is 1.5. So when you put it all in the calculator, you should get exactly 2.5. Okay. Keep on going because we have to get to 2. So what's the next x value? 0.5 plus 0.5, right? 0.5 plus 0.5 is 1. And then what's our y coordinate? It's always it's the answer of this one. So that would be 2.5. And then do the same process, add the x and y. So my x is 1, my y is 2.5, and then my delta x is 0.5, plus my y coordinate, which is 2.5. Okay, when you put it all together, you should get 4.25. Okay, keep on going. So the next x value would be 1 plus 0.5, which is 1.5. What's our y coordinate? It's this answer, so that would be 4.25. And then same process, add the x and y. So your x is 1.5 plus 4.25 times it by your delta x, which is 0.5, plus your y coordinate, which is 4.25, which is 6.875. Okay, keep on going because we want to stop at 2. So I think this will be our last one because you add increments 0.5. So it's 1.5 plus 0.5, which comes out exactly as 2. So this is where we're going to stop. And then our y coordinate is this answer. So that's going to be 6.875. And that's it. Because we don't have to go any further because they're asking what is y2? Basically, the y coordinate when the x value is 2. So your answer is going to be 6.875. Okay, so that is all Euler's method. Okay, let's do example 2. So example 2 says, consider the differential equation dy over dx equals xy over 2. There's like three-part question. So the first part says, get your slope field for the 9 points indicated on the graph below. Um, part B says, let y equals f of x with the initial condition of f of 0 equals 3. So that's the same thing as your x coordinate is 0 and the y coordinate is 3. Use Euler's method starting at x equals 0 with a step size of 0.1, or that's the same thing as your delta x. And you want to find f of 0.2, or what is the y value when the x value is 0.2. And then part C says, find the particular solution given f of 0 equals 3 and use it to find f of 0.2. Okay, so we need 9. Let's do part A. We're gonna make a table, I mean a slope field, and so you can see, what can I see? We need 9 points. So yeah, so you could pick any point. So in part A, I'm just going to pick here. Let me draw it. Okay, what if I use the point -1? So wait, what is our equation? Our equation is dy over dx equals xy over 2. And yeah, so if I do 1, 2, actually, this was supposed to be given. I didn't write it. This should have been given. I'm part of the problem. So they give you a -1, it gives you 1, and -1, it gives you 2, -1 gives you 3. This is all given. And then at +1, it gives you 1, +1, it gives you 2, +1 gives you 3. And now let's make a table. This is the answer for part A. So we have how many points? 1, 2, 3, 4, 5, 6, 7, 8, 9. Also, these are also points. 0, 1, 0, 2, and 0, 3. So our points are -1, 3. This one right here. -1, 2. -1, 1. 0, 3. 0, 2. 0, 1. 1, 3. 1, 2. And 1, 1. We should have a total of 9 points. These are your 9 points. This one, this one, this one, and then 0, 1, 0, 2, 0, 3, 1, 1, 1, 2, 1, 3. This was all given. Now we got to find the slope. So we have dy dx equals xy over 2. So let's look, here, let me work this out. So they're saying m is equal to, because dy dx represents the slope, xy over 2. So let's do the point -1, 3. So my x coordinate is -1, my y coordinate is 3, and my all over 2. And that gives you a slope of -3/2, which is like about -1.5. So if you look at the point -1, 3 right here, the slope is -1.5. So it's negative and it's slightly kind of like more, it would look something like this, right? And then let's look at the point -1, 2. So my x is, so my slope is going to be x times y over 2. So my x is -1, my y is 2, all over 2. Negative 2 over 2 is negative 1. So if you look at the point negative 1 comma 2, it's negative but not as steep as this one, so it's going to look something like this. And then negative 1 comma 1, so my m is negative 1 comma 1 over 2, which is negative 1 half. Shoot. So if you look at the point negative 1 comma 1, it's negative, but it's not as steep as negative 1, so it's going to look something like this. Okay. The next one, my x and y. So my x is 0, my y is 3 all over 2, so that's 0. How does the slope of 0 look like? It goes completely horizontal, right? So 0 comma 3 would look this point right here, and then you just make a horizontal line like that. Oops. Okay, what about the next point, 0 comma 2? So my x is 0, my y is 2 all over 2. So that's 0. So that would look completely horizontal like this. And then the next one is 0 comma 1, so that's going to be 0. My y is 1 all over 2. So that is 0. So that would look like this. Oops, this erased. Okay, let's move on to 1 comma 3. My x is 1, my 3 is 2, my y is 2, and then all over 2. That's 3 halves, which is 1.5. So if you look at the point 1 comma 3, it is positive 1.5, so it's gonna go like this. It's slightly more, it's exactly like this, but in the positive direction, right? Okay, what about the next point, 1 comma 2? So my slope is, my x is 1, my y is 2, all over 2, so that would be 2 over 2, which is 1. So it's positive, and it's not as steep as 1.5, right? It's slowly going down. Okay. And then the next one is 1 comma 1 over 2. So that's 1 half. So it's positive, but it's not as steep as 1, so it's going to go down. Okay. So that is that is the graph, that is the slope field. Okay. Part B says let f of x equals let y equals f of x with the initial condition of 0 comma 3. Use Euler's method starting at x equals 0 with a step size or your delta x is 0.1 to find or approximate f is 0 when x, we're trying to find the y value as x becomes 0.2. So we're going to have to make a table. And then we have a step size of 0.1. Or a delta x of 0.1. Okay, so it's just like the previous one that so they give us a condition of 0.3. So your x is 0, your y is 3, and uh, our delta, our m, so dy dx was xy over 2. So it's going to be my x is 0 times by y all over 2, and then it says plus y. So my y is 3. So that spits out 3. Okay. Then we add increments of 0.1. So 0, 0 plus, whoops, 0 plus 0.1 is 0.1. And then what do we put in the y? This answer. So your y is still 3. And then do the same process. So it's x times y all over 2. So my x is 0.1 times it by y, which is 3, all over 2, plus your y value, which is still 3. And when you put that all together, it should give you 3.15. Okay. Can we stop here? No, we have to keep on going to until we get the x value 0.2. So you add increments of 0.1 because that's our delta x. So 0.1 plus 0.1 is 0.2. And then my y value is this answer, 3.15. So and then it's going to be x times y over 2. So my x is 0.2. My y is 3.15 all over 2 plus your y value, which is 3.15. So actually, we could have, no, we stopped right here, right? We don't need this because they wanted to know what is what is the y value when the x is 0.2? It's this answer. So y of 0.2 using Euler's method is 3.15. So that's our final answer. Okay, now let's do part C. So part C says, find the particular solution given that f of 0 equals 3, or when x is 0 and y is 3. Use it to find f of 0.2. So let's do part C. So what we have to do is first, we got to separate and integrate, right? So our initial, so yeah, we got to separate and integrate. So my initial condition is f of 0 equals to 3. And our differential equation is dy over dx equals to xy over 2. Then what you would do is cross multiply. So step 1, separate or cross multiply. So go ahead and cross multiply. This would be 2 dy equals to dx. How about xy dx, right? And then what I would do is get all the y's and all the x's. So maybe get rid of this y by dividing both sides by y. So that would be 2 over y dy equals to x dx. maybe could maybe I could just get rid of this 2. I think it'll be easier when I integrate it. So how do I get rid of this 2? I'm going to multiply both sides by 1/2, right? 2's cancel, so you're left with 1 over y dy. And then this is going to be, you have 1/2 times x, so that's 1/2 x dx. And then go ahead and integrate. So the integration of 1 over y dy is ln of absolute value y equals to, what's the integration of 1/2 x squared? That is 1/4 x squared. And then don't forget the plus c, because we don't have an initial condition. Actually, we do. So now we have to plug, now step 2, step 3 is solve for c with the initial condition of 0, 3. So go ahead and plug in your x and y. So it's going to be ln of absolute value of y, which is 3. And then it's going to be 1/4. And then my x is 0 squared plus c. So this is going to be ln of absolute value 3 is ln of 3. 1/4, 0 squared 0 times by 1/4 is 0 plus c, so that's c. And then step 4 is solve for y. So it's going to be ln of absolute value y equals 1/4 x squared, and then we can replace our c with ln of 3, right? Now, how are we going to solve for y? Well, the clue is there's an ln, so I'm going to take the e of both sides. Okay, so over here, e and ln cancels because they're inverses, so you're just left with absolute value y, or really just y, because absolute value y is y. On the right, we have e raised to the 1/4 x squared plus ln of 3. We simplify. Wait, what are they asking on? They're asking what is the, find the particular solution and then find f of 0.2. So all we got to do is, now once we have our equation, we just got to replace x with 0.2, right? So let's do that. Y of 0.2 is going to be e, and then 1/4, and then you just replace x with 0.2 squared plus ln of 3. And that's it. Okay, the next video will be about logistic differential equations, so we're going to stop here.